Hello everyone, I'm Abigail from CLSU Chemical Society, and today I'm going to discuss errors and statistics in analytical chemistry. Okay. When doing experiments, of course, ang gusto natin ay mababa yung error na makuha natin para, of course naman, yung ating experiment ay tama and reliable. So with that, we consider accuracy and precision. So basically, accuracy is the agreement or closeness between a measured value and the true value. So dito sa accuracy, we are considering the closeness of the data that we are obtaining doon sa given na standard or true value. Samantalang sa precision naman, we are concerned to the closeness of the measurements to one another, independent to the standard value. So imagine you are playing darts. Para maging accurate ka, ang kailangan mong gawin is tamaan mo yung pinaka-bullseye. Doon sabi mo na accurate ka. Kapag precise ka naman, pwedeng hindi mo matamaan yung bullseye pero yung mga hinihit mo is magkakatabi. So, you are precise. However, of course, yung gusto nating mangyari sa laboratory is that accurate and precise yung ating mga measurements, ang ating experiments. Okay. Now, we have different ways to express accuracy and precision. So, mag-start tayo sa accuracy. Okay. So, we have the absolute error. Ito basically is just the absolute difference of the measured value and the standard value. So you just have to subtract them and get the absolute value. So ang ibig sabihin, absolute error is always positive. Consequently, yung relative error naman ay ratio lang ng absolute error and standard value times 100. Madali lang naman siyang tandaan. Okay. Next, we have ways of expressing precision. Okay. So we have standard deviation. Dito, we have two formulas na kung saan nakadepende yung gagamitin nating formula sa number of sample. We will use this formula kapag yung ating sample size is less than 30. And dito naman sa more than 30, ito yung gagamitin nating formula. Okay? And ang pinagkaiba lang nila is that yung degrees of freedom. So dito, nag--1 tayo dito. Ni-retain natin yung number ng sample size. So yun lang siya, square root of the summation of the data points minus the mean quantity squared all over n minus 1 tapos dito n lang. Okay. Next, we have the variance. Kung titingnan nyo from this slide, yung standard deviation, naka-square root siya. So, when we square the standard deviation, magiging variance siya at mawawala yung square root. Naka-square root itong standard deviation. So, pag in-square natin yung siya, pag in-square natin, magiging variance and mariremove natin yung square root. Kagaya rin sa standard deviation, nakadepende din yung formula na gagamitin natin sa sample size. So, ganun naman din, kapag less than 30, ito yung gagamitin. Kapag more than 30, more than or equal to 30, ito yung ating gagamitin. Pero, nagkamali ako dito. Hindi kasama yung 1. Scratch that, okay? Next, we have the relative standard deviation. Basically, this is just the ratio of the standard deviation, ratio of the standard deviation and mean. And consequently, yung CV or yung coefficient of variation ay ipo-present lang siya. So, S over X times 100. So, usually naman, madali lang itong tandaan. Let's have an example. So, this is the question. The following data were obtained in an experiment: 51.3, 55.6, 49.9, and 52.0. Calculate the mean, standard deviation, variance, relative standard deviation, and coefficient of variation. So, what I do is, of course, isulat ko muna yung given. Okay, so this is our data. Ang unang hiningi sa atin, well, hindi mo naman kailangan sundan kung ano yung, hindi naman particular order, pero syempre, yung mean, yung pinakamadali, we have to, hindi ko na siya in-include kanina dito sa PowerPoint because I know naman na you already know the formula for mean, which is the summation of X, just the data points, and all over the number of sample size. Number of samples. Okay. So, yan, average lang natin. Okay, so upon calculating, ito yung nakuhang mean. Now, ngayon naman, you don't have to discard your answers. Okay? Kasi sa susunod na ating kukunin yung standard deviation, we will be using that. So what I like to do kapag ganito yung problems na sinosolve ko is I like to tabulate it para mas organized at saka para hindi magulo sa paper. Yan, imagine niyo na lang may mga excuse me, may mga linya-linya at naka-table. Ngayon, nasa ano na tayo, nasa standard deviation. So, yung formula kanina is standard deviation is equal to the summation of xn, yung summation nito, x of n minus mean quantity squared. So, ayan, ang ginawa ko lang naman dito is this column minus mean, tapos in-square ko. So, ito na siya. And para makuha yung standard deviation, yung formula natin is summation of x minus mean squared all over n minus 1. So, yung n naman natin, n is equal to 4. Okay, so S standard deviation is equal to, we just have to get the sum of the data in column 2, 0.81 plus 0.81 plus 11.56 plus 5.29 plus 0.04 is equal to 17.7 over 4 minus 1 squared. So, ang ating S ay 2.429 or 2.43, 2.429 or 2.43. Now that we've successfully calculated the standard deviation at base sa sinabi ko kanina at sa given formula, yung standard deviation ay yung variance, I should say. Yung variance ay square lang ng standard deviation. So yung variance naman natin ngayon is i-square lang natin yung standard deviation which is equal to 5.9. So, yan. We're done with mean, standard deviation, and variance. Now naman, pwede na tayo mag-proceed sa relative standard deviation, which is just RST equal to the ratio of standard deviation over mean. So, since nakuha naman na natin yung standard deviation at saka yung mean, substitute na lang natin siya. 2.42 over 52.5. 52.28. Let me check. 1.3. Ayan, I'm sorry, nagkamali pala ako dito. Should be 52.2. Okay, pero tama naman po. Namali lang ako ng lagay. So, yeah, 52.2 yung ating mean. 52.2 yung ating mean. So, our RST is 2.2 over 52.2, 0.0485. Okay, now we can also get the coefficient of variation by just simply multiplying this to 100, and we will get the CB is equal to 4.65. Yeah. Okay. To summarize, nakuha natin yung mean, standard deviation, variance, RST, and the coefficient of variation. So, ang importante lang dito is huwag tayo magkamali simula pa lang kasi if we do damay-damay yung ating sagot hanggang dulo. We just have to be careful in punching sa calculator. Ganyan, kasi super dami rin ng numbers. Okay. Now let's proceed to confidence limits, which is denoted by mu and also known as the confidence interval. It is the range where the standard or true value lies. So, magbibigay ito ng range. Kaya kung makikita niyo dito sa formula, meron siyang plus or minus. So, yun yung magiging range ng kung saan natin makikita yung true value. So, ito yung formula. Mu is equal to the mean plus or minus standard deviation times d all over square root of n. So, ito nga, ito yung mga parameters. Yung mean, this is the mean, standard deviation, and sample size. And itong t is the t-value at alpha, confidence interval, and n minus 1. So, meron tayong degrees of freedom dito. So, ito, siguro wala pa tayong, pero ito na nga siya. Sasabihin ko na. Basically, nandito lang siya. Makikita lang natin siya sa table. Wait. Okay. Sa table. So, yung nakita nyo kanina na naka-asterisk dito, ayan, yun yung confidence interval. Ito siya, 90%. Minsan binibigay siya as 0.05, 0.1, 0.01. 0.01, tama. Sige, 0.05. 0.005. Ayan. So, ipa-plot. Parang ilo-locate natin dito. For example, yung sample size natin is 10. So, since yung magiging p-value natin ay, since n-1 siya, tapos ang binigay halimbawa, confidence level 90%. So, yung magiging p-value natin is this. Titingnan mo lang yung number of yung n-1, which is 9, kasi 10 nga yung sample size, tapos sinabi na 90% interval, ito yung magiging value ng E natin. This one, yung intersection ng dalawang binigay na parameter. Let's try some problems. Okay. The carbohydrate content of a glycoprotein is determined to be 12.6, 11.9, 13.0, 12.7, and 12.5 grams of carbohydrate per 100 gram of protein. Find the 90% confidence interval of the carbohydrate content from this analysis. So I already put here the formula. So what we have to do is kunin natin yung mga, since ito lang yung given, kunin natin yung mga parameters nandito. Ang kailangan natin is mean, standard deviation, and the sample size. Sulat natin yung mga given. So, I mean yung mga kailangan. Mean, standard deviation, sample size, and so, yan. Sample size is 1, 2, 3, 4, 5. 2 to 5. And yung mean and standard deviation ay you can get it the way we did kanina. One calculation, ito yung nakuha ko, and let's locate the t-value together. So, ang binigay dito is 90% interval and yung n natin ay 5. So, bumalik tayo sa table. Bumalik tayo sa table. Okay, so, ayan nga. Ang given ay 90%. So, ito tayo, dito tayo sa column na ito titingin. And we have n as is equal to 5, pero yung kailangan natin ay n-1, so 4. So, ang magiging p-value natin ay 4, so this 2.132. Now that we already got all these parameters na nandito sa formula, pwede na natin makalculate yung confidence limit equal to 12.54 plus or minus 0.4 times E 2.132 over square root of 5. So this is now the confidence intervals. Confidence interval, which is 12.54 plus or minus 0.38. Kumbaga, this term is the allowance na nagsasabi na yung value na nakuha natin ay accepted pa din. So, 12.54 plus 0.38, 12.92 ay accepted hanggang 12.92 yung maximum value and 12.54 minus 0.38 and 12.16 yung minimum value. Okay, now let's proceed to the Dixons test of QS. So, ginagamit ito for the test of outliers. Ano nga ba yung outliers? Basically, yung outliers, pwedeng marami sa isang set of data. Yun yung mga, kumbaga, nag-deviate. Parang, yun yung mga malalayo yung agwat doon sa trend. Parang siya yung bumali sa trend ng mga data. Either mas mababa siya sa normal na trend ng data or mas mataas. It is given by the formula Q value of Q calculated is equal to gap over range, wherein the gap is the absolute difference between the outlier in question and the closest number to it. and range is the difference of the maximum and minimum value. So, dito magde-decide tayo whether or not i-accept, whether or not i-consider natin na outlier yung pinagsususpetsahan natin na outlier. At yun ay mapagdedesisyonan natin using this guide. Kapag mas mataas yung kapag mas mababa yung na-calculate mo na Q value kesa sa Q table, yung pinagsuspetsahan natin na outlier ay hindi talaga outlier. Whereas kapag mas mataas yung calculated na Q value kaysa sa Q table, yung outlier ay outlier talaga. Let's have an example. In the determination of percent component in the sample, the following were obtained. So, katulad pala dun sa kanila sa confidence limit, meron ditong table. Usually naman sa stat, may mga table na basis. So, ito yun. In the determination of percent component in the sample, the following were obtained. Yan, yung values and is outlier present at 90% confidence level? If so, identify the outlier. Now dito, you have to judge kung ano sa tingin mo yung outlier. You just have to observe the data kung sa tingin mo ano yung pinaka naiba. So in here, ito magkakalapit naman sila, tapos biglang merong nag 25.55%. So I think that would be the outlier. And in order to confirm that, we have to, of course, use the formula na binigay kanina. Na Q is equal to gap. I'm sorry, I'm just using mouse sa pagsulat. Gap over range. Now, yung gap natin, ang sabi yung gap is the absolute difference of the suspected value for the 25.55 at doon sa difference ng suspected value at doon sa pinakamalapit na value sa kanya, which is 25.30. And over the range, highest value minus 25.55, highest value minus the lowest. No, I'm sorry. Mali pala. This is 26 pala. So this is, okay, ulitin natin. Hindi ko nakita. My bad. Ay. Okay. Going back. So, kaya na sinabi ko kanina, just you have to be observant. Nagkamali ako. So, yan. Ito, yung I think, pinaka nag-deviate sa kanila. So, I will be using the formula. Gap over range. Gap is the absolute difference of the suspected value, 26.21 minus yung pinakamalapit na value sa kanya, 25.55 over the range, 26 yung pinakamataas, 26 maximum value minus the pinakamababa, that's 25.26. So calculating this, 6.21 minus 25.65 all over 25 minus 25.26. So the calculate Q of Q5 calculated is 0.762. Now, so we're done with calculating the Q value. Now, ilalocate na natin yung Q table. Sometimes they call this Q critical, I guess. At 90% confidence interval. So, bumalik tayo sa table. Natakpan, pero okay na yan. So, our sample size is 1, 2, 3, 4, 5. 5. So, unlike dun sa kanina sa confidence interval, ito ay as is. Kung ano yung observation, hindi na natin isa-subtract. Hindi na natin siya babawasan ng 1. So, 5. So, 0.642 yung value nung 0.642 yung value ng Q table. 0.642. So, ang nangyari, yung calculated natin is relatively larger than the Q table. Therefore, balikan natin yung guide natin sa pagde-decide. Ito, kapag mas malaki yung calculated kaysa sa Q-tab, yung outlier ay i-reject. So, we can conclude that yung 26.21% ay outlier nga. So, the answer here is, to answer the question, is outlier present at 90% confidence interval? Yes. If so, identify the outlier. So this is 26.21. So not necessarily isa lang yung outlier sa mga set of data. So you can try it. Kung sa tingin nyo meron pa, pero for me, ito na yun muna. At least I was able to show you guys kung paano gawin. Ngayon naman, let's proceed to another statistical test, statistical analysis tool, which is the F-test. This is used to determine the significant difference between the results of two different methods based on their standard deviation. So, ito yung formula. F calculated is equal to standard deviation. No, actually, it's a variance then. Variance ng una at over variance ng second set of data. So, kagaya sa Q-test, meron din tayong guide. Kapag yung calculated natin na F value ay mas mababa kaysa sa F table, methods are not significantly different. Ibig sabihin, they are similar. Kapag naman dito, ay kapag mas malaki yung calculated ay yung method ay significantly different. Ibig sabihin, malaki yung pagkakaiba nila. I mean, considerable yung pagkakaiba ng methods. So, ito yung example. A groundwater sample was collected from a benzene-contaminated site. This sample was split into two subsamples, which were then sent to two labs for independent analysis. Lab A results were as follows. Lab B results were as follows. So, ang tinatanong, are these results significantly different between two labs at a 5% level? So, kagaya na naman din sa mga previous tests, ay meron na naman tayong table. So, dito rin meron tayong table. So, let's try it. Ito naman, this is easy kasi given na yung variance. I mean, standard deviation natin. So, yeah. So, F, we have to calculate. F calc equal to S1 squared, tama ba? Over S2 squared. So we just have to we just have to substitute this 0.0893 squared all over 0.0639. There should be a decimal point, hindi colon. Sorry. 39 squared. So yeah. Lang. 0.808089 squared. 0.0639. 1.925. So this is now our F file. Alright, so this is already our F calc. Ngayon naman, ilalocate natin yung F table. So this is given. Let's punta muna tayo sa table. Yan. So, makakaslo. Pero anyway, balikan natin yung problem. Yung ating 1.95. So, ang ating F calculated is equal to 1.95. And yung ating N1 ay 6, N2 equal to 5. So, sa F table, gagamitin natin yung F table to calculate the first F tab. Right. So, okay. So, ayan, B1 is our N1, okay? Ang N1 natin ay 6. Pero ang gagawin din natin dyan ay subtract din tayo ng 1 and minus 1. So, ang magiging position is 5. 5. And then, yung pangalawa naman, N2 ay 5. So, 4 siya. So, 4. Ayan. So, we just have to get the intersection, which is 6.26. So, yan na ngayon yung ating F table. Again, 6.26. Ngayon, to decide, our F calculated is less than F tab. So, therefore, we can conclude that so since F calculated is less than the F table, we can conclude that the two samples are not significantly different from each other. So, ayan nga, balik tayo dun sa guide. That they are not significantly different. They are not significantly different kasi ito, F calculated is less than the F table. So, ayun lang. Thank you for listening. Sana ay may natutunan kayo sa amin. And sana mag-avail pa kayo ng tutorial. Thank you so much.